Understanding the Java keywords public, private, protected. This, Super December 9, 2022. Today, I am going to illustrate the syntactic usage of a few Java keywords and a couple of characteristics of object-oriented programming with the example of a Java program that I created. I am also going to expound my thoughts and impressions while practicing these keywords. This Java program includes three public classes, namely ParentClass, ChildClass and MainClass. Neither ParentClass nor ChildClass contains a main method, but ChildClass inherits ParentClass via the extends keyword. MainClass contains a main method. The public, private, protected, these keywords are used in ParentClass, but the super keyword is used in ChildClass. The output of this Java program is displayed at the end of the code snippet, as demonstrated in the / comments. It should be noted that the this and super keywords are reference variables, whereas the public, private, protected keywords are access modifiers. Without specifying the access modifier of a variable, the access modifier of the variable is default, which means that it is accessible only within the package. The four characteristics of object-oriented programming are abstraction, encapsulation, inheritance and polymorphism. Besides, if any variable, method or object is declared as public, then it is generally considered to be universally accessible within the same package. It should also be noted that the public keyword is usually used before creating classes or defining methods instead of declaring variables or objects. In addition, in ParentClass the static keyword is added after the access modifier public for the int variable x, because it enables the int variable x to be directly accessed without instantiating ParentClass and MainClass, as a static reference cannot be made to any non-static field. As for the access modifiers of classes, only the public, abstract and final keywords are permitted. In Java, encapsulation is achieved by declaring variables as private and defining methods known as getters, setters within the same class. Getters, setters are also known as accessor, mutator methods. The syntax of getters is generally the access modifier public followed by the same data type as that of the private variable, getter name in the format of get with, representing the initially capitalized name of the private variable, followed by a pair of parentheses, an opening curly bracket, the return keyword, the private variable, a semicolon and then a closing curly bracket. The syntax of setters is generally the access modifier public followed by the data type void, setter name in the format of set with, representing the initially capitalized name of the private variable, followed by an opening parenthesis, the same data type as that of the private, a new variable of this data type, followed by a closing parenthesis. Upon adding an opening curly bracket, it is possible to set the private variable within a certain range with an if-else statement, with the setter sealed by a closing curly bracket, as demonstrated in the Java program. Within the same class, it is possible to use this keyword to differentiate between a member variable and a local variable. In the Java program, there are two variables named a in ParentClass. The member int variable is set to 6 in ParentClass, whereas the local int variable defined within this method is set to 8 in MainClass. This means that it is possible to give identical names to a member variable and a local variable with the latter defined within a method in the same class, and then use this keyword to assign different values to them. It is also possible to use this keyword to access another method within the same class. In Java, inheritance is achieved by typing the extends keyword after the child class name, followed by the parent class name. Within the child class, it is possible to use the super keyword to access any variable or method in the parent class that has not been declared as private. If the variable, method or object is declared as private in the parent class, then it is not visible in the child class, which prevents the super keyword from working properly. In child class of the Java program, it is possible to access both the protected variable y and the public method super method by adding the super keyword followed by a dot. After declaring int variable x as public static, int variable y as protected, and int variable z as private in ParentClass in a Java project in Eclipse, if I type cc.z equals with, representing any given integer, despite having instantiated child class with a new keyword as cc in MainClass, an unresolved compilation problem will still occur. Upon hovering the mouse over the red underlined letter Z in cc.z, a tooltip message pops up, indicating that the field ParentClass.z is not visible. In order to resolve this compilation problem, A quick fix of create getter and setter for Z is available. Upon clicking this quick fix, a dialog box titled Encapsulate field appears. This means that it is possible to generate getters and setters automatically. After instantiating child class with a new keyword in main class, it is also possible to access the protected variable y by typing the instantiated name of child class, namely cc, followed by a dot. This means that if any variable, method or object is declared as protected within the parent class, it is possible to be accessed via the instantiated object of the child class, which inherits the parent class. Last but not least, it is possible to declare the variables or objects as public, private or protected only when they are member variables or objects that are declared within a class but outside a main method. If any attempt is made to declare any variable as public, private or protected within a main method, then the access modifier is considered as illegal or invalid, as only final is permitted. As for methods, it is not possible to define methods within a main method. Additionally, it is not possible to use this and super keywords in a static context, which usually occurs in a class with a main method, as a main method is always declared as static. Package practice package public class parent class, public static int x, protected int y, private int z, public int gets, returns z, public void sets int news. If news 0, system.out.println data error, else z equals news, system.out.println the value of the private integer z in parent class is plus z plus, and the equals 6, public void this method int a, system.out.println the value of this integer in parent class is plus this dot a plus, this method 7, system.out.println the value of the not this integer in parent class is plus a plus, public void this method bint b, system.out.println the value of this integer b in parent class is plus b plus, public void supermethod int c, system.out.println the value of the super integer c in parent class is plus c plus, package practice package public class child class extends parent class. Super.supermethod 2, super.y equals 3, system.out.println the value of the protected integer y in child class is plus super.y plus, package practice package public class main class, public static void main string, args, parent class.x equals 1, system.out.println the value of the public integer x in main class is plus parent class.x plus, child class cc equals new child class, cc.y equals 4, system.out.println the value of the protected integer y in main class is plus cc.y plus, cc.sets 5, cc.this method 8, / the value of the public integer x in main class is 1, / the value of the super integer c in parent class is 2, / the value of the protected integer y in child class is 3, / the value of the protected integer y in main class is 4, / the value of the private integer z in parent class is 5, / the value of this integer in parent class is 6, / the value of this integer b in parent class is 7, / the value of the not this integer in parent class is 8.